Okay, now we've got our coefficients written here. And what we're going to do is we're going to draw a little box, like a rectangle. And then we're going to examine this, and from this we have to figure out what's called a k-value. And it just means like setting this equal to 0 and solving for x. So our k-value for this is going to be 1. And then we put that here. Okay, so we've got our coefficients of our numerator. We've got the k-value for our denominator. And what we're going to do is we're simply going to bring this first number down here. So this comes right down here. Then we're going to go ahead and multiply our k-value times that 1. 1 times 1 is 1. We'll write that here. We add these two numbers. 0 and 1 is 1. Then we multiply again. 1 times 1 is again 1. We add these two numbers. Negative 3 and 1 is negative 2. We multiply here and here. 1 and negative 2. To get negative 2, we add these two numbers and we end up with 0 here. So these numbers actually become the coefficients of our quadratic function. So remember how we had cubed, squared, linear term, and then our constant term? We've basically divided a cubic by a line. We should end up with a quadratic. And this is going to be 1x squared plus 1x minus 2. And so we'll rewrite that. So without the ones, we'll just simplify that. So that's our answer. This division problem generates this answer. This is our quotient. Okay, so that's kind of interesting. Let's do another one. So let's say we have negative x cubed plus 4x squared plus 9. And we're going to divide that by x minus 3. So we're missing our x term, so we're going to have our coefficients are going to be negative 1, 4. We have a 0 for our linear term, and then 9. Our k-value, x minus 3, our k-value is going to be 3, because 3 minus 3 is 0. So again, we're going to bring down that negative 1, then we're going to multiply, add, multiply again, add, multiply, and add. Okay, now let's talk about these last numbers here. These are what we call a remainder. This one had no remainder. This one, however, has a remainder. Okay, that means it didn't divide in evenly. These divided in evenly. This one doesn't divide in evenly. So these first three values are still the coefficients on our quadratic, yielding negative x squared plus x, right? Negative 1, positive 1, plus 3, plus we have a remainder. And this is kind of new. That remainder is going to be divided by x minus 3. That's our remainder. So negative x cubed plus 4x squared plus 9 divided by x minus 3 equals negative x squared plus x plus 3 plus 18 over x minus 3. Okay, so this is the operations for synthetic division, but there's more to it than this. There's something else we do to expand upon our use of synthetic division. This situation that we just did, we can also use this for something called evaluating a polynomial. So for instance, if we really wanted to know, in many ways, this 3 and this 18 here, basically if we were to take this problem and we said evaluate the polynomial when x is 3, this remainder can help us actually find out that value. So that's a lot of talk. Let me show you what I mean. Next page. Okay, using synthetic division to evaluate a polynomial. So for example, let's say we have a function, f of x equals 5x cubed minus x squared plus 13x plus 29. And we want to know, well, what is the value of the function when x equals -4? Well, we could just plug that in for x, right? Make our substitution. And we could solve that. We could simplify that. We could also use synthetic division. And so again, what we want is we want our coefficients, and we'll write them just the same way we did before. So we have 5x cubed, we have -1 x's, we have x squared, so we have 13 x's, and we have 29. Well, if we want to evaluate that when x equals -4, we just put our -4 here. And we do that same process. We bring down our 5. We multiply -4 times 5, which is -20. We go ahead and add these two numbers to get -21. -4 times -21, that's going to be +84. 13 plus 84 is 97. -4 times 97, I don't know. That's a big number. So I'll get out my trusty calculator and do -4 times 97 to get -388. And then I add that to my 29 plus 29, boop, and I get -359. Well, there you go. So the function when x is -4 equals -359. So that's just another way of doing all this math. You could also just cube -4, multiply by 5, subtract -4 squared, then add 13 times -4, and then add 29. And you should get the same answer, -359. So let's do one more. Let's do this problem. F of x equals 4x squared minus 10x minus 21 for x equals 5. So we'll just take our coefficients for -10, -21, put in our term that our value for x that we want to evaluate, bring down the 4, multiply, add, multiply, add, and that should be our answer, which we'll write like this: f at 5 equals 29. All right, that's just meant to be a nice little overview of synthetic division.